Share screen. Share. Okay. So hello everybody. Thanks for coming. I hope you're doing well. So before I start, I'll just give you a little context on who I am and how this presentation came along. So I'm a statistician in a research team in Grenoble, environmental health research team. And we are with a few of our colleagues, among who Paulina, with who we'll do a demo at the end. We're trying to do a reproducibility program in the lab. So it's sensitizing people from the lab to the concepts of reproducibility and trying to teach them the main concepts. And so one of the cornerstones of reproducibility in science, as you'll see, is Git. So in this presentation, I'll show you the goal of this presentation. Basically, it's to show you the main concepts behind Git. Not necessarily to know how to use it immediately, but for you to understand what's going on and what you will be doing when you use Git. And so I'll show you the concepts. I'll show you how we use it in the lab, which is a real life example of how you can use Git in a working environment. And we'll do a demo with Po in the end, if we have time. Well, we'll try, because it's not always successful, to do a simple show you how to collaborate on code in Git. So what is Git? So Git is what is called a version control system. What is version control? It's like when you track changes in Windows Word. It's being able to follow and track the evolution of a given file, and to be able to go back at any of its previous states at any point in time. So basically, Git allows you to do what Word does on tracking changes, but to the power 10. So Git was developed by Linus Torvald, the developer of Linux, while developing Linux, and to enable their team to collaborate on developing software on a huge scale, well, on a large scale. So Git was initially a program developed to collaborate on writing code. So uses of Git have been widened since, and in particular for the data science community, which we now use it to track a whole bunch of different files. It can be figures, data, and of course code. So these folders that are tracked by Git, these data, figures, codes within a project that are tracked by Git, is what we call a repository. So you'll hear me using the word repo a lot here. So the repo, it's all the files that are tracked by Git within a project. Git allows you to collaborate on code, as I said. It's free and open source. And so originally it's a command line tool, but now you'll see it's fully integrated in Rstudio and other Git editors, GUIs, and you hardly ever have to use the command line tool anymore. So most often when you talk about Git, you talk also about GitHub and GitLab. So what are GitHub and GitLab? They are two online hosting platforms for Git projects. So originally Git used to allow any user or any collaborator of a Git project to have a local copy of the code of the whole project, of the repo. And what GitHub and GitLab do, the main original function, is to provide an online version of the repo, which is called the remote. They also provide different functions. They enable you to have a nice web interface. They enable you to deal with issues in code in a very user-friendly way. They allow you to create a website. You'll see the Arin Grenoble website is made using GitHub, and so on. So how it works, Git and GitHub. You have so a central version of the repo, which is on your GitHub or GitLab account, which you can access directly within a web browser, because they provide a very user-friendly web user interface. And each collaborator of the project, they have a local copy of the repo. So when I say collaborator, it doesn't necessarily have to be with other people. It can also be with yourself, but working on different computers. Like if you have like a personal computer and a professional computer, and you're working on the same project with the two computers, it's super handy. It's the same as collaborating with someone else. It enables you to have like a fresh copy of the code at all times. So why use Git and GitHub or GitLab? So as I said, for us, it's mainly about reproducibility. So why does Git and GitHub and GitLab encourage reproducibility? It's because of this capacity to be able to track all that went on from the start of a project to the end. So when you are doing scientific work, which results in a scientific publication, it's super important for anybody to be able to see where you started and how you went to the final result. So this is all about sharing the code. And it's also important for you to be able to trace back all that you did to, if let's say at some point you see something that some modification, you don't know why it was done, you can go back and see why it was done. If at some point the code gets broken, you can go back to a previous version to get back to the code that was working, and so on. It's also a security. So because GitHub provides you an online version of the repo, even if something happens to your computer or to the server you're working on, you have an online version which is safe of your code. It enables collaboration, which is difficult otherwise, or much less optimal, and which happens more and more often in data science. At least in our research lab, projects are getting more and more wide and broad and involving more and more people, and we are getting progressively to have to work using Git, even if we didn't do originally. Also, just to share the code. So it's thanks to GitLab that we share the code of our publication. So now more and more, it is expected for you to share the code that produced a given set of results. And so I'll show you at the end. We have a GitLab for the lab, on which we have for each paper a repo with the code that was used to produce a paper. And also now it's very well integrated in Rstudio. So originally, like the command line format was maybe something that made that we didn't want to start Git, because I mean, I'm not a computer scientist. I do statistics, I use computers a lot, but I don't necessarily know like all the bash Linux commands, and not necessarily at ease in using command line tools. So now it's not the case anymore in Rstudio, which is nice. But so these are all the positive points, but so you have to be honest. So in the initial installation and in initial configuration can be a little complicated. So if you have issues regarding installation, so basically you'll have to make sure that Rstudio and Git and GitHub are talking together. And if you have any issues with that, it's not I won't be showing you today how to do it, because it can take a lot of time for nothing. And there is a super great documentation on how to use Git with R, which I use for most of the pictures in these presentations, and which I use a lot to learn Git in R, which is Happy Git with R. So you have the link at the end of the presentation, and just Google Happy Git with R and you'll find a website.
And also I will make just one comment. So I just make that presentation where I also explained step by step like how to make the basic installation and creation of the accounts. So I will also post the link to this at the end in the chat, so you can also find it.
Thanks. Yeah, so this was Paulina who worked in the same lab as me, and who's working on this reproducibility project in the lab. So we have a bunch of documentations that we're starting to share as we go. So this of the installation, it can be complicated, but it's only done once. So once you've done it, you're good, and you don't have to care about it anymore. And also, it is an added layer of complexity on your work organization. So you have to bear in mind that at the start, it's something that you have to get used to. And really, it's a tool you get to like and to appreciate as you use it. It's the more you use, the more you want to use it, basically, and the less you would live without it. So if at the start, it's maybe a little complex, don't worry. It quickly gets like super, like the benefits quickly outweigh the negatives. So a reminder of words of vocabulary I already gave you. So the repository is a set of files that are tracked by Git, and the remote is the online copy of the repo. So also you'll see when you create a Git project, you'll have this .git folder, which is a hidden folder which Git uses to store all the temporary data and all the history of your files, which you don't need to care about, but just need to know it's there, and it's normal that it's there. And you have a git ignore file. So this file, it's in the root of your Git project, and it's in this file that you can specify which folders you would like or which files you would like not to be tracked. So you'll see in our example, we systematically add the data folder in the git ignore, which means that no data is tracked and no data goes on GitHub or GitLab. Because we deal with sensitive data. And so you'll see that when you open a repo on a new project on GitHub and GitHub, you can specify privacy levels, like the repo can be public, so accessible to everyone, or private, just you and a given set of collaborators can participate. But even if it's private, we do not want our data to be online. So, and we cannot anyway, so that's. So in these two next slide, I'll present the two main actions in Git, which is first to commit and then to pull and to push. So first, the commit. So what is a commit? The commit is the action that will tell Git to save a given file in a given state at a given point in time. So you will have to do this manually. Git does not automatically track your files. It's you that tells every time I want to take a snapshot now and now and now and now during the evolution of the process. And you do this by doing what we call a commit. So basically a commit is a snapshot of your file. What is contained in a commit, so except for the file in its given state, you have so you have these comments. So it's very important to know when you do a commit, you associate it with it a comment. So you say in this command, well, you don't write sense, but you say you describe in a clear and concise way what was done in this commit. So you see here, so this here is the evolution of one file among several commits, so the history of a file. And you see that in these different commits, it says co-author prefers string formula method, and this says what was done in this given modification since last time. And so it's very important to write these commits well and carefully, because it's this that will give the most power to your use of Git in your project. So when you open a file, when you open the file history, you want to be able to know what was done when, to be able to easily trace back to the point in time which you want to. Also, it's very important to commit often small differences rather than not very often and huge changes, because like that you can much more easily pinpoint the point in time that interests you. Once again, it may sound a lot of work, but it's when you use it, you really understand why it's important. And honestly, if you don't do good commit commands, you lose like 75% of the use of Git. A diff, what is a diff? Is the difference between two versions of a file, between two states. So this enables you to see what was changed between the two versions you are comparing. Let's say if some part of the code is broken, thanks to this, you can maybe isolate which you need to fix. And also, it will be recorded who did the commit and when. So as you're seeing the history, you see exactly who did what and when. Okay. Also, this number here, this code is what we call the hash. So Git gives a unique identifier to each commit. That's how it works. Not important to remember, but if you see this code, don't be surprised. So committing is saving snapshots of a file locally. Very important. So it's all the modifications that you do on your computer that you want to save from time to time. Now, when you're collaborating, you want to be able to send your modifications to the collaborators, and also you like collaborators to be able to send their modifications to you. So the two actions to share commits and modifications in files are the push and the pull. So the push is when you have commits on your local repo and you want to send them to the remote. And the pull is when you want to synchronize your local version of the latest version of the code on the remote when you want to get the modifications on your computer locally. So here we have the example of a user here in yellow who has modified twice the file here. He pushes the two commits on the GitHub remote, and the other collaborator in red here, he pulls the two modifications that were done by here in yellow. So as you understand, only modifications that you specifically committed will be pushed and pulled. So regarding recommendations on how to pull and push, so it's recommended to pull very often. So you have like the freshest version of the code on your computer all the time. And very important to pull before you push, because it's when you, so it can happen that, let's say, two collaborators modify the same part of the code at the same time differently in push. This will create a conflict. So the conflict, it's the most difficult thing to think about and take care of in Git, and the most sensitive. So now most editors have like a visual way of doing it, which is super handy. And the best way to deal with it is to avoid them. And so one way to avoid like problematic conflicts is to pull like the latest version of the remote on your PC before you push. Like that, you could, if there's a conflict, it happens on locally. Like that, you can see you can change the code on your side to solve the conflict before you push your modifications. Donc you can only push what you have committed, of course. So here you have, so this is a reminder of the main actions we talked about, and these correspond to the git command. So init and clone is to either create a repo or to download a repo that was created already. Adding and committing are the two steps of committing. So you'll see in the demo that to commit a file, you have to first what we call stage it. So it's one process, but it's divided into actions, and push and pull. So one last functionality, which is very handy, but which I won't go into too much because it's a little more complicated, is the branching system. So this allows you to have parallel versions of the same code. So while keeping a master version, which is functional, and enabling you to develop, let's say, new functionalities. And once you are satisfied with them, merging them with the main master code. So this is another way of showing it. So let's say this is the master branch, which is functional. Two other functions are developed, and once the users, the developers are happy with them, they can merge them back to the main branch. And like the main branch will contain the modifications from the two development branches. And so to summarize, when you compare a workflow with Git compared to the classic, well, I don't know classic, but the workflow where you do not use Git. So the first A and C, the first line is, imagine a user working on his own that would like to work on a code and have several versions, and at some point you don't know which version is what, or you have done a modification, you cannot go backwards because you cannot remember what went wrong and at what point. So Git provides you for each file a history like this, where you have each successive modification that's recorded with a comment, and you can go back in time and get the file back in its state at the moment of the commit, which is super handy. And the second line is the same thing when collaborating. So this is when Git really gets to the most of its power. So without using Git, when you would be sending mails with different versions and different names, version A, B, C, final, etc., which gets messy very quickly, Git would provide you for one. So you would just have one file with the same name that everybody's working on. And if you would look at its history, you would see all the different commits, the different steps that went on, what went on when, and I can get the file back in its state at any time. So everybody who's worked with another person on a document knows about this. So this I already talked when I presented the action. So commit frequently, really take time. It's worth taking time writing the commit comments. I mean, it doesn't even take time. It's just a habit to take to think about what you're writing. And do small commits often rather than large commits not often. Pull often and pull before you push. So now I'll quickly show you how we use in Git in our lab. So of course, not everybody uses it, but people are progressively getting to understand how everybody can benefit individually and as a team of using Git. So we each have a personal account which we use for our personal projects. I mean, I'm a statistician and I have a lot of projects for which I work only on myself. So very, very important for us, and I guess for a lot of people doing this in research, we never track the data. So we have all my data is stored in a data folder, which appears in the Git ignore. I'll show you what it looks like after. And so no data is tracked. And if a collaborator starts to work on the project, I will transfer the data to him or her in another way, like via USB or a secured transfer system. And we each have personal accounts, and we have a team account, which is used for sharing code for publication. So this account, all the repos are public. And this is what we use to share code. So I have it here. So we have a repo per paper. And we have we have started sharing the useful documentation that we're producing, and like the one we are doing for this presentation. And so how I use Git personally. So how I said I have my GitLab account, which I use mainly. I use the team's account from time to time to share the code of a publication. Once the publication is out, basically, I get the final code, put it online, and put it there. And also some of the researchers who are starting to use Git to just get to pull what I'm doing. So they don't really use it to work on Git, but it's just like an evolved Dropbox, basically. So every report I have, I just put it in my folder, they pull, and we communicate that way. It avoids a lot of sending emails back and forth. So this, as I said, I have one Git project per analysis, per project. So here is my projects folder. So each paper, basically, I have a project. So it's an Rstudio project, which is synchronized in Git. If I look within a project, so you'll see the classic like structured data, documents, etc. You see the Git folder and the git ignore file, which I talked about. So the Git folder you can ignore, and the git ignore, as I said, is where you specify all that you want not to be tracked by Git. So this is where it's a simple text file. I put the data. You can put whatever. You can put heavy. Also, most often you do not synchronize like heavy documents or whatever. And I have for each project the remote on my GitLab account. So here are a bunch of useful links. So you'll find the presentation on our website soon, not yet, but soon. So links to presentations I used, to Happy Git with R, of course, and to our GitLab account if you want to have a look. If you're like in a research team and trying to think about how to use Git in your team, this maybe it's, or if you have comments for us. And that's it. So before I take questions, I will just ask Paulina. So Paulina, do you mind if I take a few questions? We see how it goes, and if we have time for the demo.
Yeah. Okay.
Because the demo, so for the others, we have done already, and it's on YouTube already. So maybe it's better if we see if people have questions, we answer. And if we don't have time, I'll send you a link to the demo we have done already. And if we have time, we'll do it live. Paulina,
yeah. Do you want to take questions like from people talking to you, or you want me to read them? Because I was writing them down when they were appearing.
Oh yeah, so if
talk. What do you prefer?
Yeah, let me know if people ask in the chat if they have questions. I didn't look at it yet.
Okay, so there are questions in the chat, but maybe we have a few minutes just that people, if they want just to speak with you, or if they want to turn on the mic and just ask.
Okay, yeah, if you have questions, yeah, you can turn on the mic if you want, or ask in the chat. It's maybe easier on the mic.
Let's start with the mic. If nobody wants to speak, I will just tell you briefly.
So, okay, first question I see, what is the difference between GitHub and GitLab? So yes, I was expecting this one. So basically there are two online platforms to host Git-based projects. I'm guessing the most popular is probably GitHub right now. The reason why I talk about GitLab also, so people can join in after if they have additions, but I think historically, at least in France, labs used GitLab because at some point you had more control on the privacy options. I think GitHub, it enabled you less easily to have private repos, whereas GitLab it allowed it for free. And I think historically that's why in research where you have more sensitive data and code, we were using GitLab, and I stick to GitLab for now I have both, but I think that's why GitLab is used more in research. And GitHub I feel is better on developing new functions and in an easier manner. Like doing a website, it's super easy in GitHub, and it's a little more complex in GitLab, and that's what I think that's why. The main functions are the same, basically. And the way you use it in Rstudio, it's the same. So So
there was one more question about because you said at some point that you wanted that there should be a pull before the push, and there was some confusion. The readers were not really, didn't understand what did it mean. How can you pull before you push? Can you like repeat one more time?
Yeah, okay. So basically, when you pull, it's the action that synchronizes the most recent version of the code in the remote on your computer. So of course, before you send your modifications to others, you want your code to be the most up-to-date possible regarding the other people's modifications. And like that, if you see that if you have modified something that they have modified also, you won't break the remote. It will just be local. So you can fix it local before you push it. Does that make sense or not? Paul, do you have a more comment?
Maybe the person who asked this would like to comment. But then, so Agnes was asking how to save data in gitignore to avoid sending it to the GitLab. But this will be, we can show it during the demo, yeah. Right?
And I just showed you an example. You just have to add the name of the folder in the file. It's a text file. What about Bitbucket? I think Bitbucket is another similar service. I don't know. I haven't ever used it.
I don't know either. No,
yeah. If you can you collaborate with users using GitLab? Good question. I'm guessing not, because the remote in your in a Git project is the central like the reference code, and the remote is the one that's stored on.
But what you can do, you can push to both, right? You can have both. You can push your push may push your information to both repositories or more repositories as you like. So you cannot really directly collaborate not having account on both, but you can just solve it this way if you really need.
Maybe I don't know. And what is, so a lot of questions about Git and GitHub. Difference between Git and GitHub. So Git is the language of version control. They all use the same language. It's like R is Git, and Rstudio and VS Code is GitHub, and GitLab is how you use Git. I don't know if that analogy is more clear than what we explained. One is the actual language, and the other it's the provider on how you use it. Does Git allow user control, such as one user must have contributions? Well, what GitHub and GitLab allow is for you to set levels of how do you call it? Like you can have people that are allowed to see your code and not edit it, and so which are called guests, and you have people who have several levels of permissions and up to maintainer, which everybody who's a maintainer can like modify the code, add other people, and so on. So it's through GitLab and GitHub that you decide the level of each member of the project. During a group project, one of the members was not counted as a contributor, yet he pushed some parts of the work. I'm guessing it has something to do with his account, but I'm not sure about it. I don't know. I'm sorry. Probably.
There was one more question in the very beginning about the two-step authentication. I think. Do you want to comment on that, like how to push to GitHub with this two-step authentication?
Sorry, I didn't hear you very well. Your sound was not very high.
Okay, so there was one question from Michael. Maybe he would like to ask it by himself about the two-step authentication from being asked by GitHub.
Yes. And what was the question?
Wait.
Can I ask verbally?
Yeah.
Oh, perfect. We found you.
Yeah. No, I've been watching. It's been fantastic. Thank you very much. Yeah, I don't really understand the difference between the two methods. One using HTTPS and the other using SSH. And I understand. Well, I got a message from GitHub that they are phasing out password control and moving towards two-factor authentication. So I moved early to two-factor authentication, and now I've got stuck. I've got a barrier I can't get past. But my particular problem I can sort out, but perhaps the general principles of SSH and HTTPS and authentication would be really useful to know about.
Yes, so very good question. And unfortunately, I won't be able to answer very precisely because I'm not an expert on these topics. But basically, it's two different ways. So you have different ways of making sure that Rstudio and GitLab are communicating in a secure, like protected manner. One is using SSH, one is using HTTPS. And this is actually, these the main problems when you install it and have issues is coming from this. And it's very well explained actually in the Happy Git with our documents. So if somebody has good notions of the differences between HTTPS and SSH, please feel free to jump in. I'm sorry, I don't have a better answer.
Okay, so I think there are no more questions in the chat at least. So shall we do the demo?
Yes.
Or?
Okay, yeah. So what we'll do now, hopefully we'll have time, should be okay, is just quickly show you how to create a project, modify it, and collaborate on it in Rstudio. So I try and comment as much as I can as I'm going along, but feel free to intervene if you have questions. And turn on the mic because I won't be looking at the chat too much. So how I do it, so this is just one way to do it. There are several ways to do it. So I'll just show you how I do it. Is first of all, when I have a new project I want to start, let's say a new analysis for a new paper, I go to my GitLab account and I open a project, new project here. So for the sake of this demo, I'll just do a blank project. So the first thing is to give your project a name. So experience taught me that it's actually pretty important to choose wisely the name of your project, because it's pretty hard to change. You can do it, but when you're collaborating, it can create a lot of issues, and you'll be using this name a lot when you're working on it. So choose wisely. We'll call it test project. So this is the name of the project. This is the URL. So usually it's your GitLab handle and the name of the project, but you can change it. So this is where you set the level of visibility, or private, which is you only plus people you choose can have access to it. Oh, I just saw it. Are there rules to from the project name? So this is something I would like somebody to tell me. So I know it's recommended to use a hyphen and not underscore in the name, and of course like short and concise. And I don't really know why. I should know, but I don't.
Matthew, you are asked to zoom your screen if you can. Can you?
Is that better? Okay, and so public, everybody can see. Okay, create the project. So here we have an empty GitLab project. So the next step is to create your Rstudio project and to link it with the remote. So this is Rstudio. So in Rstudio, you create a new project under version control using Git. So here, what I do, again, several ways of doing it. Paulina will show another. I just copy paste the link of the project into my into the Git Rstudio project opening. So it will be in my projects folder with the name test project. Find create project. Okay, so we did this demo already with Paulina and I forgot to remove it. So I just quickly remove it. And I'll do it again. Version control. Create projects. Cloning. So actually, I'll open the Explorer. Wait, what am I doing here? So you see that now I have this new project that's open. So it's a classic Rstudio project with the rproj and the rproj user file. And you have these two additional folders, which is the Git folder, which for now contains this, so you never open it, and the Git ignore file, which I talked about. So this is a text file that you can modify. So you have all that we talked about here, okay? So now my first step will be to create a document in my new project. So I'll just do, sorry, I'm tired. So I just basic R markdown file, test document, here, save. So I created this test document, which appears in my folder. And most importantly, it appears also here. So in Rstudio, all that's to do with Git appears in this Git panel. So on my computer, it's on the top right, but it could be elsewhere on yours, depending on your window view. So here, as soon as you modify something since your last commit, it will appear in here. So to get more detail, you click on the commit button to open the GitHub window, the Git window, and here you see all the files that were modified since last time. So because this is new, it's all green here because it's created, and so in this window here you'll see the diff. So the difference between last time when it's created, it's all new, so all green. So first commit is init because it's the initiation of each document. So this is the window where I write my command. Once I'm done, so important also, so you choose which files to commit by clicking the box, and then you write your message and commit. So you can do several commits with different commands using the tick box. Now I commit them all using the init. I have a message, 3 files changed, 47 insertions, perfect. So now these modifications have been saved by Git locally, but they do not appear yet online. So what I do to send my commits online, I do a push. So now what I'm doing, the files I created locally, I'm sending to the remote, which is the GitLab. So now if I refresh my GitLab remote, so here I'm on the web browser, you see here the project, which contains the new files. So this test document here, I can click. So the little comment here you see, sorry. So this is the comment of the last commit you'll see. It says who did it, Mathieu Roland, me, 59 seconds ago. So perfect, everything went well. And now, so I'll give the hand to Paulina. She will create the same project and clone the repo on her computer, modify a file, and send modifications back.
Did you invite me to this project?
No, I forgot like last time. So I'll share my screen again. So before she's allowed to work on this project, I need to grant her access because the repo is private. Settings, members here. What is it? It's not Paulina?
Oh. Yes, it was with the error. So Pau, Pau, J-E.
Yeah, I got it. So I'll grant you, so
yeah,
the different permissions you can grant a member. So I'll give her the maintainer access, like that she can do anything, invite. And now I will stop sharing and give the hand to Paulina. So now she just appeared here as one of the members of the project. So I think
I cannot share the screen, I'm sorry. You have to permit me.
Now we should be able to.
Okay, so basically to collaborate with Matthew on this project, I have to first sign into my GitLab. So this is my GitLab website where I'm already signed in. You cannot see the project that Matthew just shared with me because probably I need to refresh the page. Yeah, so I refreshed the page and the project appeared. So now I can enter the project and I want to clone it by Rstudio. So basically I can either copy the URL of the project or I can push the button clone. And here, this is also referring to the previous question. There are two types of authentications that can be chosen. So I will copy the HTTPS one. I'm switching to my Rstudio and I do exactly the same what Matthew did to create a project. So I'm creating a new project which will be under version control of Git. And I'm simply pasting the URL to the repository URL. I also choose a place where this will be saved. And I create a new project. Okay, it took some time. So now I have exactly the same version of the project that Matthew has on his local and remote, and I can make modifications. So someone asked about the git ignore. So basically, yeah, it's just that you just type the name of a folder, for example, folder data. We don't have this folder, but you can imagine that this would just now, everything that's in the data folder will be not synchronized with Git. So let's make a small modification. I'm opening one of the files and I'm removing a part of it. And now I want to commit this change so Matthew can also synchronize his project with this change file. So basically you see that there were two files that were modified. So I have to commit them. So first I'm staging them, marking for the Git to follow them. And I make a commit. Let's say that I will commit just one of these files, the one that I remove the plot from. So my commit message in formatted one will be to remove the plot. And I'm committing. So now you see that one file out of two files was changed. There were 8 revisions. And I make a push. So that you can also see the changes. Okay. So it's done.
Okay, perfect. So let me share the screen now. Paul, maybe you can turn your mic off because you have a lot of distortion going on. I don't know why. Thanks. So, so now this is the project. So if I refresh the page, we should see some modification going on. So this is on GitLab. This is my remote. So here we see that now the last commit for this document was to remove the plot 50 seconds ago by Paulina Ilinak. Perfect. So now the modifications of Paulina have been pushed to the remote, and now I want to pull them locally on my computer. So super easy. I go into the Git panel of my project, and I just press on the blue arrow, which is to pull. So I see documents that were changed, one file changed, test document with 8 lines removed. Perfect. And now let's say I want to do a last modification, and then we can see the history of the file. So, oh, and interestingly also, we can see she modified the git ignore, but did not commit and did not push. And we see it does not contain the data that she added. That's because she didn't commit and push. So adding text paragraph, blah, 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 save. So now I want to save these last modifications. I open the Git panel. This document, I choose to select it to commit. I see that in green what was added since last time, since the last commit. So it's this adding text paragraph. So I'll add my comment add text paragraph, commit, and save. So now the very important, interesting feature of Git, one of them is the history. So it's here, and if you saw in the Git panel, you have a history button. So you click it, and you see the history of all the commits of the project. And so if you want to see the history, so here we see the init, which was my first commit. Then Paulina, she removed the plot, and then added a text paragraph to the RMD. And so if I want to see what the RMD file was like in its first state, I just have to click on the first commit, search for the RMD, and click on view file. Okay? When you click on a commit, you see all the files that were modified in this commit, and you see the file just before they were, well, after they were committed. Here, so this is the markdown after the plot removal, before the text paragraph addition. So I think these are the basic functionalities in Git, which can get more complex, but we just wanted to show you like the main concepts and not go into depth and try and stay not too confusing. So maybe we can resume to questions again for those who have some. So did you see Paulina in the chat maybe? Where is it?
Yeah, I hope now my computer is a bit less loud. Basically, there was one question from Benoit. How do you update the data files during the project? So I'm not sure.
If that's concerning the way I work, it is not. I just update it externally. I add files. I add files from outside, like I would get a USB or something. It would not be updated through Git, and same for collaborators. And this can happen like you add a data file in your data folder, you forget to tell the collaborator, and he has an error because he doesn't have the path to the data because he doesn't have it locally. So this is, when you work in this way, this is something you have to keep in mind. Can you actually push before committing by mistake? Yes. You will just not push the modifications. Committing is just staging all the different modifications you want to memorize before pushing them. Is it possible to create the new package? So this question, I'm sorry, I don't understand. How do you update the files during? Does anyone who wants to work with your files have to have an account on GitLab? Yes. Yes. And because so the person needs to have an account on GitLab mainly for me to grant her as a contributor. Can you demonstrate how to go back to a previous version on GitHub? Do you mean so? Joseph, do you mean on Rstudio or on GitLab? So while Joseph, he elaborates.
You can just show in Rstudio, so maybe it will be.
Yeah, so in Rstudio, basically, you just, it's in the Git panel here. Click on the commit. And so if you click on the history button here, you have all the commits. And if you have done your commit comments correctly, you should know at which point you want to get your file. So let's say I didn't want to remove the plot in the end. So I can just click on the init commit, which still had the plot, and click on the view file here button of the text document RMD here, which shows me the document with the plot. And so if you want to keep your version, but just copy paste the plot and add it back later, this is something that's easily done.
Yeah, but actually this is not really, I mean, this is something that I would just say, yeah, this is possible to do, but it's rather not really, that there is a special way to reverse the commits. But
Yeah,
this
but
is
I mean,
not, it's impossible to be done from the Rstudio. So what Matthew showed is a nice way just to have a look. Copy pasting, I would say, yeah, maybe it's not the most efficient way to reverse the whole commit.
So very interesting question. If you update your local version of code and then pull the latest version before pushing, do your local changes get overwritten? Yes. So when you pull, you are ready for all uncommitted changes to be changed. So everything that you want to be saved, you have to commit. So the pull, like that, you can say which code of the pull you want to keep, or which modifications you want to keep. When you want to create a new file, do you create it inside your R project and then commit it? Yes, exactly. Once actually, once the project is initialized in GitLab or GitHub, I never go there. The only time I go is either to create or to share my code with others. I just send them a link and they can access to the code without having to put everything. I just take a couple of more questions, and unfortunately I have to go after. Committing just saves the changes locally, right? Yes. Thank you. Well, it changes them locally, but also it saves them in the history. So even if you overwrite it, you'll be able to revert back to the changes. Okay, one last question randomly, which I haven't answered, and then I'll stop. So for DevTools, I mean, I know DevTools, but I didn't understand the question. I'm sorry. The processes are the same for a local repo. What do you mean? Okay, so I'm sorry. I'm going to have to end the session. So I will put this session online. Feel free to go and check our calendar. So we have 2 more before the summer vacation. So in June, it will be about time series. And in the end of May, it's a surprise for now. We cannot say yet. We need some confirmation that it's okay, but it should be interesting. So stay tuned and subscribe to the emailing list. I mean, that's the most reliable source of information. So, and this you can do through the website. So I just quickly send the link to our website, and then I'll say bye-bye. So this is the link to the sessions. Chic. This is the link to the YouTube channel. So thanks a lot for attending, and see you soon. I hope it was useful.
Thank you.
Bye-bye.
Bye. Bye.